In the previous videos, we've tried understanding the very first searching algorithm, that is linear searching algorithm, right? In this video, let's quickly write the same thing using C++ and let's move on to the binary searching algorithm in the next videos. So as it is our first searching related implementation, what I want to do is I want to create a new folder called searching, in which I want to organize all my searching related implementations. So in the searching folder, whatever I have created, let me just create a new file called linear searching.cpp. Okay, so in this file I'll be implementing the linear searching algorithm according to the pseudocode that we have written. Very simple. We will go to each and every value there that is there in the array. If at all if the value is matching with the value that user has passed, we will simply return the index. It's as simple as that. Okay, for that implementation, let me just pull in the basic template that we need. Along with that, we also want to pass the array of values, right? So let me just include the vector as well. Okay, now here, like any other implementation that we are doing, let me just write another class called linear searching. Okay, in this class, let me just add a public method that basically implements the linear searching algorithm. Now, whenever we are getting a array of values, right, and user also passes the value that needs to be searched in those array of values. In the end, if at all if that value is available at a particular index in the array, we need to return that specific index. If the value is not found at all, even after checking the entire array of values, we will simply need to return -1 or something that is according to your requirement. Here in this specific implementation, we will be returning -1. So the return type of the function is obviously integer, right? Because either we are returning -1 or we are returning appropriate index at which we found the value that user is searching for. So the return type of the function is int, and let's name the function as linear searching, and it will basically take a integer array of values. It also takes the value that needs to be searched in the given array of values. Now this value needs to be searched in this array of values and we need to return the appropriate index. Remember that whatever the linear searching algorithm that we are implementing, right, it really doesn't care whether the array is sorted or whether the array is not sorted, or if the values are arranged in a particular distribution. It really never cares about the way the values are arranged in the array that we have got. Rather, it will start searching for the value that user has passed right from the first element to very last element. At any given position, if the value is found, we will simply return that specific index. For that, I'll simply write one for loop. I will simply start from 0 and I need to go till the very last value, right? So that is nothing but array dot size, and in each and every step I'll move on to the next index if the value is not found. So here, if at all the value at ith index in the array is equal to the value that user has passed, what we need to do, we simply need to return the index I itself, because the value is found at that specific position. Okay, it's as simple as that. If the value is not matching, I gets incremented, and again the value at that specific ith position again gets compared with the value, and the process goes on till we find that specific value or till we go to the very last value we have in the array. Once we reach that very last value and we are done with that specific comparison as well, if the element is not found, we need to return -1. So that is the return statement that I have added outside the for loop. Okay, so that's all the linear searching algorithm implementation is. Now let me just close this, put this semicolon to complete the class definition, and let's just say the values that I want to pass for linear searching algorithm is, let's just say I want to pass 1 2 3 4 5 6 7 or and 9 also. Like I mentioned, it really never cares if the values are arranged in a sorting order or non-sorting order. It really never bothers. All we have to do is go to each and every element and search it. Okay, now let me just create the object of, I think I gave a spell mistake here, li linear searching, and let's just follow the same thing here, ls. Now using this object reference ls, let's just call the linear searching, and let's just pass the values arr or and along with that, the value that I want to search in the given array of values is, let's just say I want to search 12, and it will basically return the index at which, if at all the 12 is found in the array, right? Let's just store that value in some variable called position, and we can print it on the console. So cout position end line. Okay, that's all there is. Now let's run the program that we have written here, run code. If I choose run code here, see the output that we have got is -1, because whatever the value that we are searching, 12, is not there in the array of values. For example, let's just say the array of values that I have passed is something like you see on the screen. I just modified the value 2 to 12. So if I run it once again, element at index 1 is nothing but 12, right? That is the output that we have got here. Okay, once again, one more definition I want to show is, I just want to pass some non-sorted array. Let's just say 199, 12, whatever it is. So in this also, naive approach or linear searching algorithm is something that will absolutely work. So if I just run it once again, it should pass index 3. See, that is the output that we have got on the console. Okay, so that basically validates the linear searching algorithm implementation using C++.